Okay, this one is the part 2 video of the numerical. In this numerical, you can so here the figure is shown. You need to understand for this figure, conical flax is here. This conical flax, and this conical flax is attached to a U2 manometer is connected. The reading of the manometer given in the figure shows when vessels is empty. First one is the when the vessels is empty. Find the reading the manometer when the vessels is completely filled with water. Second case is completely filled with water. When the vessel is empty, so let's calculate the pressure from the datum line x-axis and the equate. The right limb is equals to left limb. So on the right limb, left limb, so pressure is due to this 20 centimeter height on the mercury column, and this left limb, the pressure is due to this height, this H1 height. So calculate specific gravity is to both specific gravity water is 1, both is given, density of the mercury and the water is none, and equating the pressure is in the right limb, and this one is for left limb, this one is for right limb. Then after this one is calculation, and this one is for, and H1 value is calculated as follows. And for the second case, if the and we need to find the, for the second case the vessels is full with the water, that this means this vessels is full with water, this is full with water. If this conical flax is filled with water, then height and the level of the mercury, then the level of mercury here decreases in the right limb and increases in this limb. Mercury level increases in left limb, decreases in the right limb. Why? Decreases by some height and increases by some height. Okay, increases by something like this, same decreases by y and increases by y. Yes, so here we need to draw the another same figure and then they calculate. Here this one is the diagram. The liquid is filled here, that means the water is filled here, so that due to this pressure this mercury will decreases by y amount. The height of the mercury decreases by y amount, and here increases by y amount. This is the increases, this one is the increases, this one is the increment, this one is the increment, and this one is the increment. So this is Z, the new line, Z dash. This one is the new datum line. Above this datum line, here is the y, and here is also y increases, here is also y times the increases. So we need to, in the left limb, we need to calculate the pressure is pressure due to 2i centimeter height plus the pressure due to 20 centimeter height in left limb. In the right limb, we need to calculate the pressure due to 3 meter height, and after this pressure due to, and the pressure due to H1, pressure due to this H1 plus H1 height, and after this pressure due to y height. Okay, we need to calculate in the right limb, likewise in the left limb. So let's calculate the everything. So here pressure in the left limb equals to pressure in the right limb, left limb density, and this one is the acceleration due to gravity, and 0.2, and the 2 times the y. Here is the water, acceleration due to gravity, height 3, that is the 3 meter height, H1, pressure due to, and the y meter. Okay, after this calculation, After this calculation, and we will get the result, and the reading of the manometer is follow, and this is the reading of the manometer height. Okay. Okay, here is also another important question. This question says about that this one is a simple, the right limb. Okay, this one is the YouTube manometer. The YouTube manometer is connected to a water pipeline, which is in excess pressure, excess atmospheric pressure, which is in the excess atmospheric pressure. The right limb of the manometer contains the mercury and is open in the atmosphere. The contact between the water and the mercury in the left limb determines the pressure of the water in the main line if the difference of the level of the mercury in the U-tube is 10 centimeter and the free surface of the mercury is in level. And with the center of the pipe, that means the free surface, this one is the free surface which is in the center of the line. This free surface is with the center of the line. We need to calculate the figure first. If the pressure of the water in the pipeline is reduced to, that means if the pressure of the water line in the pipeline is, okay, if the pressure of the water in the pipeline is reduced to 921 pressure in the water line, we don't know, we need to calculate from the first given this data, and calculate the new difference in the level of the mercury and sketch the arrangement, that means diagram in the both case. Okay, let's do it. Here we have the diagram already, so we need to equate the pressure in the both case. So far the difference in the mercury is 0.1 meter, and the arrangement is first here is the arrangement, and P naught PA, this one is the pressure, this one is this pressure due to water pressure, and pressure due to 10 meter pressure at A, and pressure due to 10 centimeter height in the left limb of the water, that means PA plus P rho GS. Okay, we need to calculate this one first. This one first. Let's calculate this one first. Pressure at a B point. We need to calculate the pressure at a B point again, and then after we need to calculate the pressure at a C point again, and the pressure at a B is equal to pressure at a C. So pressure at a B, and here is our pressure at a C. So pressure at a B is calculated by pressure at a and pressure due to 10 meter pressure at a and pressure due to this 10 meter height, this 10 meter height from this line to this line, pressure due to this 10 meter height. Here is this one, and so PA plus 981. After pressure at a C equals to pressure at a D plus pressure due to this 10 meter height, pressure at a D plus pressure due to 10 meter height. So pressure at a D is 0 because no increase in the height, 0, and the pressure at the P naught rho naught G naught. So here calculate another 31 after a simple calculation. So equating the pressure at a B and the pressure at a C, we can calculate the pressure at a. Equating this, we can calculate the value of the pressure at a, which is something like this. And in the second part, here is asked in second part, it says that the pressure is reduced to 9,810, but the actual pressure of the water inside that pipe is 12,000. If the pressure is reduced, this means if the pressure is reduced in the left limb, that means the pressure is reduced. This means if the pressure is reduced means the, look at this, and the second part given pressure is given pressure here for the second part, given pressure is 9,820. The new difference of the and we need to calculate the new difference. We need to calculate the new difference of the mercury level. The arrangement is shown below. In this case, the pressure at A is 98020, which is less than 12,360. Hence, the mercury in the left limb rises. That means the pressure decreases in the left limb. That's why the mercury in the left limb rises. The rise of the mercury in the left limb will be equal to fall of the mercury in the right limb as the total volume is conserved in the pipe. Okay, for this let's make another figure here. Okay, this one is the figure. This is the figure. Here the decrease in the height, here the decrease in here the decrease of the mercury in the right limb, and same the increase in the mercury in the left limb by x amount. This one is the x amount. So again let's calculate the pressure inside the A. We know already, and we need to calculate the pressure due to this. The pressure due to this, how much due to this? 10 minus x centimeter height. Again the pressure at a D, asterisk D, pressure at this D1, this D, pressure at this D, and pressure due to this pressure due to this 10 minus 2x height. 10 minus 2x height. This one decreases by 2, and this one again. Here is also x. Increment, decrement. Okay. New level is this one is the new level. This one is the new B asterisk, and the C asterisk is the new level. So this total is the this one is the from this one to this one is 10 centimeter. So x is manipulated, x is negative here. So again for this to this is x, but this to this is, again we need to subtract this one, and we know the 10x, and this one is the x. So we can calculate this to this one is the 10 minus 2x. Okay, and the everything, so we can find the value of the x. Likewise, pressure at A, pressure at this one, pressure is a D stick, pressure due to 10 minus 2xt. After the simple calculation, we can obtain the value of the x is this, but we need to find the difference of the mercury. Difference of the mercury means that here is also mercury. Look at this difference of the mercury. How can you calculate difference? Here is one mercury, here is the level of mercury, and here is the level of mercury. The distance between these two lines, means that this one 10x minus 2x, 10 minus 2x. This 10 minus 2x, the difference of the new mercury level. This one is the difference of the new mercury level. So we can calculate that these types of problem by equating the pressure on the two sides.